In this video I'm going to quickly run through how to write the formula of ionic compounds. Before I show you the shorthand of how we're going to write that, I just want to explain a little bit about where it comes from so you understand it and you're less likely to make mistakes. Here I've got an ionic reaction. I've got sodium, which is a metal, reacting with chlorine, which is a non-metal. Because sodium's in group 1, it's got one electron in its outer shell and it wants to lose that one electron to have a full outer shell. Chlorine's in group 7, it's got 7 electrons, it wants to gain 1 so that it has a full outer shell. Sodium loses 1, chlorine gains 1, which means I only need 1 sodium and 1 chlorine for them both to have a full outer shell. When sodium loses, it has a positive charge. When chlorine gains, it has a negative charge. And my formula for sodium chloride is going to be NaCl, because I only need 1 sodium for every 1 chlorine that I have. The charges plus and minus balance. But if I were to change that and I were to use magnesium instead of chlorine, you will see that because magnesium's in group 2 and needs to lose 2 electrons, that 2 chlorines are needed. Chlorine is only ever going to gain 1 electron, so if I've got a metal that needs to lose 2, I'm going to need 2 chlorine atoms. Magnesium loses both of its electrons, it ends up with a 2+ charge. Each chlorine gains 1 electron to end up with a minus charge. But you can see that my charges still cancel out. I've got 2 positives in total and I've got 2 negatives in total. But my formula for this time for magnesium chloride is MgCl2. Okay, and I use that small 2. And that tells me that every time magnesium reacts with chlorine, I need 2 chlorines for every 1 magnesium I have. Look at a slightly different example. This time I've got sodium reacting with oxygen. Sodium, as we've seen already, is in group 1 and wants to lose 1 electron. But oxygen is in group 6 and it needs to gain 2 electrons for that full outer shell. Because each sodium can only lose 1, I need 2 sodiums to provide oxygen with the 2 electrons that it needs. Again, sodium loses 1 and takes on a positive charge. Oxygen gains 2 and has a 2 negative charge. But my formula is going to be Na2 and an O. That tells me when sodium reacts with oxygen, I need 2 sodiums for every 1 oxygen so that everything ends up with a full outer shell. Rather than drawing out these dot and cross diagrams, which take up a little bit of time to work out how many metals and non-metals are needed, you can just use the charges on the ions because they form the same charges every single time. So if we look here at our periodic table, any of the elements in group 1, okay, hydrogen excluded because hydrogen is a non-metal, but all of my group 1 metals, they will always form ions with a +1 charge because they always lose 1 electron. In group 2, they always lose 2 electrons, so always have a +2 charge. In group 3, my metals lose 3 electrons, so have a +3 charge. I'm going to move over here now. Group 0, they have a full outer shell. They don't need to lose or gain electrons, so they don't have a charge. Group 7 have 7 electrons in their outer shell. They want to gain 1 more. If they gain 1, they have a -1 charge. Group 6 have 6 electrons. They want to gain 2. They have a -2 charge. Group 5 have 5 electrons in their outer shell. They want to gain 3 to give them 8. They have a -3 charge. Then I get here to group 4. They've got 4 electrons in their outer shell. So do they lose 4 and have a +4 charge, or do they gain 4 and have a -4 charge? And the answer is neither. Okay, your group 4 elements don't form ionic bonds. They form covalent bonds instead, and they don't form ions. So when you're doing ionic bonding, you're going to get something from group 1, 2, or 3. Paired up with something from groups 5, 6, or 7. So these are the charges you need to know. +1, +2, +3, skip 4, -3, -2, -1. And once you know those charges, it becomes a lot easier to write the formula of ionic compounds. So for example, if I was trying to write the formula of sodium nitride, I would go to sodium and I would see that it was in group 1 and therefore it's going to have a +1 charge. I would go to nitrogen and see it was in group 5 and therefore has a -3 charge. And I know my charges absolutely have to cancel out. I've got 1 positive, but I've got 3 negatives. That means I'm going to need 3 sodiums for every 1 nitrogen that I have. 3 sodiums will give me a +3 charge in total. The 1 nitrogen gives me a -3. The charges cancel out and I get Na3N. If I look at another example, let's look at magnesium oxide. Magnesium's in group 2. That means it's going to have a +2 charge. Oxygen's in group 6 has a -2 charge. In this case, I've got +2 and I've got -2. Those charges immediately cancel out. I don't need to add any extra numbers. I just write MgO. You can use the charges to work out what the formula will be, but do not include charges in your final answer. The formula for your ionic compound should be charge-free. The charge is balanced, therefore there's no need to include them. It's not charged overall. If I look at another example, what about calcium fluoride? Calcium's in group 2, it has got a 2+ charge. Fluorine is in group 7, it has got a -1 charge. I've got 2 positive charges, I've only got 1 negative charges, therefore I'm going to need 2 fluorines. Now I've got 2 negative charges to cancel out my 2 positive charges. Slightly harder one, aluminium oxide. Aluminium's in group 3, it's going to have a +3 charge. Oxygen's in group 6, it has a -2 charge. So if you're not particularly good with maths, it might be a little bit harder to see how you're going to get these charges to balance. I've got +3 and I've got -2. How am I going to get these to balance? The easiest thing to do in this situation is write down the symbols for your elements, again, exactly the same order, and then cross over the numbers from the charge. Oxygen is -2. So the 2 that's up there next to oxygen, I'm going to cross over and bring down here next to aluminium. I'm not bringing the minus, I'm just bringing the 2. Same here, I've got a 3 next to the aluminium, I cross it over and bring it down next to the oxygen. I bring down the 3, I don't bring down the plus, and that's going to be my formula. And if we look at this, if we've got 2 aluminiums, each aluminium has a +3 charge, that means I've got +6 in total. I've got 3 oxygens, each with a -2 charge. I've got -6 in total. So by crossing over those numbers, they have cancelled out. And that will work for everything. If we look, for example, at lithium oxide, lithium's in group 1 with a +1 charge, oxygen's in group 6 with a -2 charge. If I cross over those numbers, so I write down the elements again, the 2 that's next to the oxygen comes down next to the lithium. Again, I'm bringing down the 2, I'm not bringing down the minus. The 1 that's next to the lithium comes down next to the oxygen. I bring down the 1, I don't bring down the plus. And this tells me I've got 2 lithiums, so each one has a +1 charge. That gives me +2 in total, cancelling out the -2 on the oxygen. So that will work for all of them. But remember, if you had something like this, magnesium oxide, you don't need to cross over the numbers. If the numbers, the charges immediately cancel, no numbers are going to be needed in the formula. So +2 -2 immediately cancels out. You don't need to cross over the 2's. I'm going to give you a few ones to practice for yourself, and then we're going to have a look at formula involving polyatomic ions. So have a go at doing these ones. So sodium bromide, sodium fluoride, sorry, there's a flare. Sorry, we'll take it from there. Why is that flare so bad? That's not enough. Do sodium fluoride, magnesium bromide, and aluminium chloride. So press pause. I've given you the ions. Press pause, have a go at doing that for yourself, and then come back when you're ready to see the answer. Okay, for sodium fluoride, you should have gotten NaF, magnesium bromide is MgBr2, aluminium chloride is AlCl3. Obviously, I gave you the charges there on the ions, but you are not going to get that in the exam. You need to be able to use your periodic table to spot what the charges are going to be. The next thing we're going to look at is we're going to look at writing ionic formula when you have got polyatomic ions. And there's a couple of polyatomic ions that you need to know the formula from, and you literally just need to learn these off by heart. One is hydroxide, it's got an OH- charge. Another is nitrate, NO3-. You need to know sulfate, which is SO4-2-. Carbonate is CO3 2-, and the other one you need to know is positive, and it's ammonium. So ammonia is NH3, ammonium is NH4+, and you just need to learn these off by heart. If we look at an example, let's try and write the formula for lithium nitrate. Lithium is in group 1, it has got a +1 charge. The formula of a nitrate ion is NO3-. +1 - 1, those charges immediately cancel. so I don't change a thing. I just put the formula together and I get LiNO3. Look at the difference in the ending of the name here. Nitrate, the last time we had nitrogen, it was nitride. If it ends in IDE, then you've just got one element. So nitride ending in IDE, I've just got nitrogen. But when it ends in 8, which you'll see it does over here, 8, 8, 8, that means you've got the element, so nitrogen plus oxygen, the element sulfur plus oxygen, the element carbon plus oxygen. So when you see those 8s, that's when you know you've got a polyatomic ion. It's the element plus oxygen, and you're going to need to know the formula. If we look at another one, let's look at sodium sulfate. So again, sodium is in group 1 with a +1 charge. Sulfate is my polyatomic ion, SO4 2-. I've got +1 and I've got -2. These charges do not cancel out. I need 2 positives, so I'm going to need 2 sodiums, Na2SO4. Okay, and again, if it was sodium sulfide, it would just be sodium and sulfur, but sodium sulfate is sodium, sulfur and oxygen, and I'm using that sulfate ion. If we look at a slightly harder one now, I'm going to do calcium hydroxide. So I've got calcium, Ca2+, and I've got my hydroxide ion, OH-. So hydroxide, hydrogen and oxygen, OH-. I've got 2 positives, I've got 1 negative. So I'm going to need to have 2 of these OHs. And the common mistake is to write OH and to write it 2. Okay? If you write it like this, this formula says you've got 1 calcium, 1 oxygen, and 2 hydrogens. You don't want just 2 hydrogens. You want 2 hydrogens and 2 oxygens. You want 2 hydroxides. So I need to put a bracket around the OH so that that 2 applies to the whole hydroxide ion, not just the hydrogen. If we look at another example like that, if I do aluminium nitrate. Aluminium's in group 3, Al+3. Nitrate, again it ends in 8, so I know it's NO3-. It's not just nitrogen by itself. I've got +3, I've got -1. So I need 3 of these nitrates. So I'm going to write down my aluminium, and I'm going to write down my nitrate, which is NO3, and I need 3 of them. So I'm going to put a big bracket around the NO3, and then I'm going to put a 3 on the outside. So notice that when I'm adding the number, I am not changing the formula of my nitrate. That NO3 has got to be in my answer. All I'm doing is putting a 3 in the bracket outside. We can also have a look at, give me another one, I'll have to multiply. I'll do aluminium sulfate. So aluminium sulfate. Again, aluminium is Al+3, sulfate SO4 2-. I've got +3, I've got -2. So in this case, I would cross over my numbers. That's the easiest way to do it. The 2 that's next to the sulfate is going to come down here next to the aluminium. Okay, so remember, when you're crossing, you're looking at the charge. I'm not looking at this number 4 and crossing that over. I'm looking at the charge on the ion. It's 2-. I bring the 2 across, I don't bring the minus across. Then I look at the charge of my aluminium, it's +3. I don't bring the plus, but I'm going to need to bring that 3. The SO4 cannot be changed. It has to be SO4, but the 3 is now going to come down here on the outside. Because I need 3 SO4s, I put the SO4 in a bracket. Have a go at doing a few of these for yourself. Let me scroll. Again, sorry, there's a bit of a delay. That. Oh, it's better. Have a go at doing these 4: calcium sulfate, lithium hydroxide, potassium nitrate, and calcium hydroxide. Again, I've given you the ions. You're not going to get that in the exam. You do need to know them off by heart. Okay, so there you've got your answers: CaSO4, LiOH, KNO3, and CaOH2. Okay, final thing we're going to look at is getting the ionic formula for something that involves a transition element. So they can ask you about the transition elements, which are here in the middle. They could ask you about iron, or they could ask you about copper, they could ask you about zinc, and you'll see that because they're not in the main groups that we typically study, that you can't work out from the periodic table what the charge on that metal is going to be. Because they are all metals, metals always lose electrons, metals always form positive ions. I know they're going to be positive, but how many electrons do they lose? Are they going to be +1, +2, +3? That you are going to get from the name of the ionic compound. So if they tell you you've got iron 2 oxide, that tells you that you've got iron, which has the symbol Fe. I know it's plus because it's a metal, and that 2 in Roman numerals tells me that it's got a +2 charge. Oxygen's in group 6. Got a -2 charge. My formula will be FeO because the charges immediately cancel out. They could then ask you another one, iron 3 sulfate. In this instance, again, I've got iron, but because I've got a 3 in Roman numerals, it's +3. It's not +2 anymore. The sulfate is the SO42-. These charges are not cancelling out. I'm going to need to work it out. Again, when I'm doing this, the 2 that's part of the charge in the sulfate is going to come down here next to the iron. Not the 4, that's not going to move. It's the 2 I look at. I bring down the 2, I don't bring down the minus. Then I write down my sulfate. I cannot change the formula at all, so I'm going to be writing it as SO4. I need 3 of them, so I put that in a bracket, and I put the 3 on that side, and that's iron 3 sulfate. I'll just give you one to do. You can do copper 1 oxide, and then have a go at doing copper 2 sulfate. So just press pause and have a go at doing copper 1 oxide, copper 2 sulfate. The symbol for copper is Cu. Okay, that's going to be answer. When it's 1, it's got a +1 charge, and I need 2 of them to cancel out the negative charges on oxygen. When it's +2, sulfate is -2, and they immediately cancel out. The only other thing that they could ask you is they could give you the formula of something. They could say work out the formula of the ions. In iron oxide. All right, I know oxygen's in group 6, and oxygen always has a -2 charge. But how am I going to know whether iron is +2 or +3? All right. In this case, you'll need to look at how many irons were needed to cancel out the negative charges on oxygen. So I know that oxygen. Wait, have I done this right? Apologies. That's not right. I should have done that the other way around. Fe2O3. Apologies. I know that oxygen is always going to be -2. I don't know if iron is +2 or +3. So I need to look at how many oxygens were needed to cancel out the charges on iron. Because oxygen is -2 and I needed 3 of them, that means I've got a total charge of -6. Therefore, I must have a total charge of +6 coming from the iron. If I need 2 of them to give me a total charge of +6, then each iron must have a charge of +3, because 2 of them would then give me +6 to cancel out the -6 from the oxygen. If I gave you another one, if I gave you CuNO3 times 2, and they asked you to work out the charges, all right, I know nitrate is NO3-. It's always got a minus charge, but I don't know what charge is on the copper. I know it's going to be plus, but is it +1? Is it +2? If I needed 2 nitrates to cancel out the charge on copper, it means I've got 2 negative charges overall. That must mean that copper has a +2 charge. +2 from copper, and now I've got -2 from the 2 nitrate. So you can use the formula to work backwards and work out the charge that's on your transition metal. Copper and iron, the charges can vary, but you are expected to know that zinc has a +2 charge and lead has a +2 charge. They're the transition metal, so you can't just look at the periodic table, but they both always have a +2 charge, and they do expect you to know that. So copper and iron, it will change, and you'll work it out from the formula. Zinc and lead, it won't change. It's always just going to be +2. If you're feeling comfortable with working out ionic formula, the next video is about writing full balanced equations. If you're not comfortable with writing ionic formula, well then go back and watch some of these examples again and just practice doing the questions before I actually write them out. Make sure you're getting the same answer as I am each time.